negative 1 4/5 times 1/6. And this works out really well for us because we have we got a mixed number that we're going to change to an improper fraction, and then we're multiplying it by another fraction. Do we remember what the rules are for multiplying signed numbers? Forget the fact that they're fractions and mixed numbers. We did an activity just before this where we let you play around with different multiplication and division problems that had signed numbers in them. And I think one of the things that I've learned, as I've done this for many years, is to write down the type of number that we have above it. The negative 1 4/5 is a negative number. Just put a quick N above it to kind of make that more concrete in our mind. 1/6 is what type of number? It's positive. So I'm going to put a P there. And when I multiply a negative number times a positive number, I have to recognize that I'm going to end up with what? Yeah, I'm going to end up with a negative answer. Our rule tells us. It's kind of like, let's simplify this down. If I had $3 worth of debt, which would be a negative number, if I had negative 3, and I was multiplying that by, let's say, 4 piles, well, my answer would be $12 negative dollars, right? Just because I'm multiplying by a positive doesn't mean that it's going to change it at all. It's just saying, okay, I've got this group of negative 3, and now I've got 1, 2, 3, 4 groups of negative 3, which is a total of negative 12. So let's apply that knowledge. We already know we're going to have a negative. Trey, tell us how you went ahead and changed 1 4/5 into an improper fraction.
So you have to multiply negative 1 and negative, you have to times negative 1 in the denominator, and then you add the numerator.
All right, don't worry about the negative so much because we know our answer is going to be negative. So really, let's write down 5 times 1, and we're going to add the 4, which is the numerator. So denominator times our coefficient, and then we're going to add the numerator. And then the denominator is going to continue to remain the same, correct? And we're going to multiply. We're going to figure out what that numerator is going to be, but we're going to multiply it once we're done by 1/6. Okay, let's see if I can keep this all in the picture. Five times 1 is 5. Plus 4 is going to be 9. So now I have the improper fraction of 9/5. Well, let's not get ahead of ourselves too much. I do want to multiply that by 1/6. Now, wait a second. You know that I'm a big fan of the word or, right? Before we multiply, is there something that I can reduce or change in these fractions before we multiply to make it easier to multiply, and of course make it easier when we get our answer to simplify?
You forgot to make the 9/5 negative.
Yep, you're right. 9/5 is going to be negative, and that just reminds us that we have a negative answer, but I already know my answer is going to be negative. That's why I put that there at the beginning, right? Do you guys see anything from the top and bottom that a number can divide into to make them reduce? What did you say? 9 and 6. What can divide into 9 and 6? The number 3. So another way that we can say this, 6 can become a 2. So now 1/6 is actually going to be 1/2. And negative 9/5, 9 can become, 3 goes into 9 3 times. And now we've reduced our fractions down to a point where when we multiply, we're going to multiply numerator times numerator. So this is going to be negative 3 times 1. And denominator times denominator, this is going to be 5 times 2. All right, what's negative 3 times 1? Negative 3. 5 times 2 is 10. We can go ahead and write this as negative 3/10 or negative 0.3. We talk a lot about tenths being the king, right? And the reason I say that is that when we have a fraction that is in tenths, we automatically know what it looks like as a decimal number. So no matter, I don't know what Trey's question asks for, if it asks for a fraction or mixed number in completely reduced form, or does it ask for a decimal, he's got both answers anyways. So that's going to work out for us. So the second one, I wanted to do an example where we have two negatives that we're multiplying together, two rational numbers, but both of them in this case are negative. And this is the rule that really tricks people. When we multiply a negative times a negative,
We get a positive.
we do. We have to remember that we're going to get a positive answer. So again, just like we did in the last example, we're going to multiply 6 times negative 1. 6 times negative 1. I should just do, we know the answer is going to be negative. Let me just make that a 1. 6 times 1. And then we're going to add 1 to that result. That's going to be over 6. And then we're going to multiply that by negative 3. But wait a second. We want to make negative 3 into a fraction. How do we do that? Negative 3 is an integer. How do we turn it to a fraction? Negative 3 over 1. Because it's a whole, because it's not a whole number, it's an integer, right? Anytime you want to make a number into a fraction, put it over 1. All right. 6 times 1 is 6, plus 1 is 7. So now I have 7/6 times, this is negative 7/6, let me make sure I have that, times negative 3 over 1. Again, I know my answer is going to be positive due to a negative times a negative. Do you guys see anything that can reduce before we multiply?
The 6 and the 3.
Yes, the 6 and the 3. How many times can 3 go into 3? Once. How many times can 3 go into 6? Twice. So I'm, again, going to write that word or, and I'm just going to rewrite it so that I don't make a mistake in multiplying. Oh my gosh, wait a minute. What's 1 over 1? That's just 1. 7 times 1 is going to give me 7. 2 times 1 is going to give me 2. We already know our answer is going to be positive because it's a negative times a negative. And finally, what's another way that we can write this improper fraction as an answer? 2 goes into 7 3 times, and that means 2, 4, 6 of these 7 are used.
Which gives us 1 left.
We have 1 left over, so we have the fraction 1/2. What's another way that we can write this in decimal form? Well, let's do this first. Can we change 3 1/2 to tenths?
Yeah.
If we looked at our jump count, let's see, 1/2 could change into 5/10, and then that gives us 3.5 because we know the 5 is in the tenths place. Guys, this is the process. You guys went through. You have every single answer that they could possibly want. All right? Great job.